Across industries, data workers spend over 40% of their time searching for and preparing data rather than deriving insights. My name is Paul Nashawaty. I'm the practice lead for the AppDev practice at theCUBE research, and I'm joined by Mathew from ParallelWorks. Mathew, how you doing?
Hey, Paul, doing well. Thanks for having me.
Awesome. Why don't you tell the audience a little bit about yourself, a little bit about ParallelWorks?
Sure. Yeah, I am CEO and co-founder of ParallelWorks. We are a 10-year-old software company that's aiming to make high-performance computing and large-scale computing more accessible for organizations. We've been working on this mission to democratize computing, regardless of the type of scheduler interface or underlying hardware. And excited to tell you about what we're doing and how we're making an impact.
Well, excited to have you here. This is a really important topic. I mean, when we talk about these inefficiencies that we kind of led the conversation with, they really need to be solved, right? I mean, there's automation and orchestration to help with complex workflows. This includes spanning compute, data movement, cluster management, and access all across cloud, on-prem environments. And often, this is how organizations are really achieving their goals. So a unified control plane really helps avoid that manual setup. Also, it helps with data staging delays and fragmenting tools, right? So I think, Matthew, there's a lot here that we can kind of talk about. And essentially, it's just, we're looking at the pain points that a lot of teams are dealing with is wasting hours and daily on prep and infrastructure tasks instead of innovation, right? And we all know that developers want to innovate, right? So I want to start with a question here, Matthew. When we look at R&D teams, they often face delays due to fragmented infrastructure, manual processes, and complex provisioning across hybrid environments. So these inefficiencies usually slow down innovation, they waste resources, and they really reduce the overall impact of high-performance computing investments. So with that, why do you think organizations, or what organizations are most common workflow bottlenecks when managing these projects and workloads across hybrid environments?
Yeah, great question. Everything you just unpacked there is kind of the mess of the world that we live in. And our software tries to help organizations tackle that. And today, a lot of organizations, infrastructure teams, which are the people within the organizations that are managing the computing environments, they're, kind of part of this mess of maintaining the systems that they're having their end users connect to. And it becomes a very challenging job, especially in this world that we're in today, where computing environments are moving very quickly. They're evolving into accelerator systems, GPU systems. We're starting to see quantum clouds come out and people experimenting with them. And every time new types of these systems come into place, the infrastructure teams need to adapt and figure out how they're going to bring those into the organization and control them, put guardrails around them. So in the case of variable infrastructure costs, they don't become the Wild West and explode because they can get very expensive. So in terms of the bottlenecks, it's these organizations having to bring in specialized people to manage, for example, their cloud environments, or we need to bring in an expert to bring in our new Kubernetes cluster that we just bought from NVIDIA or AMD. And every one of those is kind of a whole different animal in terms of making it usable through the organization. And that's kind of part of the slowdown in bringing these type of systems online. And when I say online, it means about bringing them out to the end users. When these organizations make the computing environments available to the end users, there's a different set of bottlenecks that appear there. Every type of system that end users interact with have different ways to interact with it. And I'll kind of give some examples. Today, a lot of the GPU systems that you're seeing people buying or, starting to operationalize within their organizations, they're using Kubernetes. Kubernetes has an entirely different syntax from the old batch scheduler systems that for decades, many R&D organizations have been using, whether in SLARM or PBS and things like that. So every time these organizations roll out a new type of computing environment, whether it's a hyperscale cloud, a neo cloud that's running, virtualized hardware with GPUs, we just bought our new GPU system and it's now running Kubernetes. The end users have to go through this bottleneck of usage. And again, to exactly your point, that distracts them going in and focusing on their mission. What is it we're trying to solve? So that's what I would say. Those are the bottlenecks that we see, both from the end user side and the infrastructure team side.
Yeah, I mean, it really does make a lot of sense. I mean, when we think about the impacts to these organizations, there's a number of areas, whether it's the infrastructure or the Kubernetes clusters or skill gap issues, complexity, all of that needs to be addressed in ways that's going to make it more streamlined effectively. I mean, we're finding that in our research that organizations are looking at, utilizing multi-cloud environments. Right? In fact, we see that many organizations are using, actually, we see that 94% of organizations are using 2 or more clouds. 65% are using 4 or more clouds. And that just increases the level of complexity, right? And then we also see that you mentioned Kubernetes clusters, especially when we start building out these AI kind of environments with GPUs and such. There's a big factor about portability as well, right? So we see that 20% of organizations state that application portability is critical to their environment. 67% say it's very important. So effectively, portability is important. But Mathew, I got to talk about the fact that like one piece that you touched on, which is around orchestration, is how does automation and orchestration really change the pace of productivity for these R&D teams?
Yeah, that's a good question. So I'd say when organizations can start automating the way that they provision the resources and then make them available to their organizations, it gives and I'm going to go back to the stakeholders that like we work with all the time, which is the infrastructure teams and the end users. It's those two things. On the infrastructure teams, these groups are constantly being challenged with doing more with kind of less, right? The end users that are consuming these resources are growing, and they don't necessarily have the ability to bring in a giant team that can scale when an organization starts going into the tens, hundreds, thousands. We're talking to people that have tens of thousands of users of these computing environments. So automation is really the key that allows the infrastructure teams to roll out the computing systems in a way that can be contained and guardrailed and delivered to the end users, in a good user experience, I guess I would say. So I would say that, again, we're focused on trying to get the end user practitioners out of the business of creating the plumbing. And, when an infrastructure team says, hey, great, all these users can come in and now use AWS, or they can use, Together AI or whatever, choose your provider. They don't have to get in the business of now trying to create all the automation layers around that, because there's tools like ours, control plane tools and softwares that exist to be able, that already have taken care of all that plumbing, so to speak. And so it allows.
Yeah, it's really, So, sorry, I didn't need to cut you off there, but it's really funny you use that analogy, because it's almost like you are listening in on a conversation I have with other analysts on my team, where we talk about, I always kind of somewhat joke, as I mentioned, I cover the app dev practice and I focus on the business logic up, and I look at infrastructure as just at the plumbing. It just needs to work. If the plumbing just works, then the app dev team can do their jobs. So I think, Mathew, I think you're spot on, actually, because you want to almost extract that layer from the app dev team so they can be productive and focus on day 0, day 1, day 2, and DevSecOps, and focus across the CI/CD pipeline and the SDLC.
That's even happening more too. I mean, I think even today, I'm sorry to interrupt you too, but it's the infrastructure is becoming even more abstracted, and from an end user delivery perspective, and when they go into the neo clouds of the world, they're trying to offer managed services on top of their infrastructure. Organizations want to roll those things out as well. So it's just becoming more in the background because the end users can get their work done that much more effectively.
Yeah, I mean, make no mistake. When I think neither you or I are saying it's not important. It's very important. It just needs to work, right? It just needs to work effectively. I think one of the things we talk about, we talk about these applications, we talk about the challenge of these different infrastructures, different kind of ecosystems that the organizations are working in. data is a critical part of the organization, right? Data movement is also a big part of how applications are leveraging they call it the lifeline of the business, right? So when we think about the challenges around data movement and cluster provisioning, also workflow execution at scale, I like when we were talking before, Matthew, we were talking about the kind of concept and delivery of using a unified platform and how it can help, but also have the ability to have the practitioners using their bespoke solutions, but still have a unified approach. Can you talk a little bit about that? Because I think that really helps with businesses achieving their KPIs.
Yeah, I can definitely do that. And I'm recalling our previous discussion about it for sure. So yeah, you hit on it. Data, we see data as the glue that holds these environments together. A lot of times the file systems and the storage systems that hold the data today are a little bit siloed and isolated away and kind of sitting next to the computing environment where that's happening. I think there's a big trend in that changing right now. And you have a whole, group of global namespace providers that are aiming to deliver a unified data layer across wherever your computing's happening. And to me, that's music to my ears because we're the compute software that moves the task to the compute. So data is the glue. Global namespaces are coming in that can kind of start to unify these things, which make our job, like as a software provider that delivers computing tasks across heterogeneous resources, that much easier because again, the users don't need to worry about moving the data explicitly anymore. That's the goal that a lot of these groups are trying to achieve. Business as usual today, sitting in these monolithic siloed storage systems, the end users have to move their data from site to site. If I need to go out to a Nebius cloud because I need to burst out for GPU capacity, I have to do an actual explicit jump over to that storage, to that resource, stage my data over, do the job, stage it back. And this whole crop of global namespace providers is trying to remove that entire step, which is great. On the cluster provisioning side, and this is a little bit more of the world that we kind of live in the environments we operate, either private clouds, public clouds, Kubernetes clusters. What becomes a big challenge with cluster provisioning, and we're not really doing cluster management, but we are provisioning resources in the shape of clusters when our customers want us to do that, when the software demands it. You start to realize that it does really become a full-time job maintaining the technology changes and evolution of the infrastructure on the third-party cloud services that you're using. AWS, Azure, Google, Oracle, any of the neo clouds all handle provisioning and allocation of their resources in different ways. They call things differently. For example, they all have different interconnect bypass layers that you can call on for tightly coupled jobs that, all the computers work together. Maintaining that, especially as you just mentioned earlier, with the percentage of companies having to go to multiple clouds because of technology or economic reasons or capacity, is really a difficult task to do. People think it's easy and we can go on to, XYZ provider and start using parallel cluster service or cycle cloud, but doing that at scale in an organization across multiple really becomes a big challenge.
It's a challenge, yeah, for sure. And and I think when we double click down on that, right, we have to ask ourselves here, what impact this has on time to insight or cost efficiencies, especially after you adopt a centralized control plane for compute resources, right? Because that's a piece that I think there's a before and after scenario here. When you look at that, Matthew, it's more about utilizing a unified view, having a centralized control plane, but also harmonizing across those multi-cloud instantiations. What are your thoughts?
Well, yeah, I'll comment on the before picture because it's kind of the world I'm living and breathing every day in a way. Like typical, organizations that we're talking to today, they're not generally using a tool like what we're creating. Like the concept of a computing control plane really isn't in their, repertoire. So it's going from a world of like duct taping all these different environments together, and you're getting mandates to go to cloud perhaps, and we want to use a neo cloud provider because we want to rent GPU capacity before we get our own system in 12 months or whatever. It's just kind of duct taping or working around the complexity problem, and the infrastructure teams get stretched as kind of we were saying. So this world of like after now, when when these organizations realize, maybe it would be helpful to have a centralized compute layer or a software layer that can plug in these different systems, regardless if it's ParallelWorks or any of the other ones that do exist today. I'm kind of saying more generally, at some point there is a realization that, maybe it would make sense to do that. And then it becomes a time and ROI piece. The time it takes for us to implement this ourselves and grow like FTEs because we need our Azure expert, or we need our Kubernetes expert now, or multiple as the organization scales, traded off of the ROI of bringing in a software that can manage that and roll it out into very large scale organizations and have a proven track record, is kind of, the realization that I think we're starting to see, right? And I think that the adoption curve on that is still pretty early, I would say. But honestly, like the whole hybrid and multi-cloud concept, I've been doing this 10 years as kind of like this company we started 10 years ago. It's kind of, I've never heard it said more in the last like 18 months than I ever have. So it's still kind of picking up.
Yeah, well, I mean, I agree with you, right? And I want to ask you, in your experience, right? When you look at this, how important I talked about earlier on this in the session here. I talked about portability, right? And I'll kind of connect that into reproducibility as well. How important are workflows, portability, and reproducibility across a multi-cloud or hybrid deployments? What I guess I would ask is one is how important it is, and two, how well are the current tools today are meeting those needs? Because I mean, that's a big challenge, right?
Yeah. So I would argue that, and probably most organizations would argue, that portability and reproducibility are critically important. Reproducibility, kind of from a provenance perspective, and people are using these a lot of times, to like, do drug design and you need to keep a detailed record, or you're doing, you're replacing physics code and like physical wind tunnels with like virtual wind tunnels, and you need provenance of that. So being able to go back even over years and replicate the exact thing you did is critically important. Portability, I think, is important in a different lens, where, as I kind of mentioned before, like the environments are changing and evolving, and being able to kind of move along the track of the evolving infrastructure is really important. And kind of in those examples I gave earlier, where you may have an organization today that wants to go out and rent GPUs on a neo cloud, and they want to start experimenting with their production ML pipelines that are going to become front office and going to be critically important, but they just placed an order with NVIDIA or AMD, and in 12 months they'll get that on the floor, commissioned in production. Getting them into an environment where they can start building their workflows today, or their workloads today, on the rented infrastructure, and then as their on-prem infrastructure comes online or colo comes online, seamless portable move over. And yes, Kubernetes does some of these things, but managing multiple Kubernetes clusters across environments starts to become its own challenge. So being able to have that flexibility to move into these quickly adopting environments, and even as like quantum starts coming online, and it's going to be probably a similar thing. Oh, you have a quantum cloud you can start placing tasks on. It's giving flexibility to do that. Yeah.
Yeah, I agree. Yeah.
I'm sorry. And then you're just real quick, the second point on current tools, containerization is great. Kubernetes is great in coming on. Managing those things at scale at an organization, when you go from 10 to hundreds to thousands of users with an infrastructure team that is not necessarily growing at that same rate, is the challenge, right? So that's where this world of computing control planes, single pane of glass, middlewares lives. And I think you're seeing a lot more of these things kind of crop up nowadays. And, Parallel Works Activate is just one of a few of them. Yep.
Right. Oh, I mean, you're right. I mean, future innovation, what I heard you say is future innovation and the ability to scale your current projects is key to success. And, I know we're kind of coming up at the end here. There's the audience that's watching. Mathew, where would you recommend them go to learn more about how they can get started, whether they're early in their journey here or they're like very mature and they know what they're doing? What would you recommend them to do?
Yeah, that's a great point. And I think you probably heard, I probably didn't say Parallel Works or even what our software Activate specifically does compared to others. This is more, trying to, this is about solving problems in organizations that I'm seeing, where this tooling layer that maybe is pretty early in the adoption curve is starting to play a real role in ways that, I think are critically important and will be in the near future. So we're a small company. That said, we have deployments with, very large customer bases, infrastructure teams supporting hundreds, thousands of users. So happy to talk to anybody about where they're at in the journey and can kind of meet them where they are. Is this the right time for a tooling layer like what we're doing? If not, we're usually very transparent about that. Like, oh, you don't really need something like what we're doing today, but maybe in, a year you will. So we're very happy to have that conversation. I think there's some other kind of material out there that we've been publishing lately on how to right size your infrastructure. And we didn't really get to like some of the ROI of doing this, which is about cost efficiency and charging back your resources within an organization. And we have some material on that could be useful for groups to look at. So yeah, happy to get in touch. You can visit our website and, contact us that way for sure.
Well, Mathew, thank you very much. I mean, Parallel Work sounds like it's a great kind of start to look into how to solve some of these challenges. There's a lot to consider, obviously, as we went through this presentation. Mathew, I want to thank you for your insights and your time today. It's been great having you on the show and the episode. And I want to thank the audience who tuned in. We really appreciate you being part of the AppDevANGLE community. But for now, that wraps up this episode. We'll be back next Wednesday with another conversation to dive deep into the tools, trends, and talents that shape the future of application development. Whether you're deploying at the edge, building an AI, or modernizing your cloud stack, we've got you covered. So be sure to follow us on social. And if you have any thoughts, questions, or just want to connect, you can always reach out to me at pauled@siliconangle.com. Until next time, stay curious and stay building. Thank you.